In this video, I'm going to take a look at the last three graphs here, cosecant, secant, and cotangent. So cosecant we know is the reciprocal of sine, and so I'm going to go ahead and press play. And you get a pretty cool looking graph here. Okay, so what exactly is going on here? Let's take a quick look. I'm going to pause it. We've got several things going on. One is we have the sine curve. So do you see this point here is really connected with the sine curve. So if you want, you can scroll down and you can turn the sine curve off by pressing this little folder. And that just leaves you with the cosecant curve left. Okay. Now, if you look at the sine curve related to the cosecant curve, how are they related? If you remember, we've been thinking of them as reciprocals. Sine and cosecant are reciprocals. So we're going to have to see it here. Maybe I'm going to change. That wasn't what I wanted to do. There we go. Let me see if I can change the y-axis to go up by 1. There we go. That just gives us an idea. Approximately, what is the y value here? Oh, there it showed up. The y value here is roughly negative 0.5, or 1/2. What's the reciprocal of negative 1/2? Well, it's 2. Do you see that this is close to 2 now? We're off just a little bit. But if I adjust t, oh, it disappeared. But what I want you to see is these are always reciprocals of each other. And so right here, you get an asymptote. Let's pause and think about why that happened. Why did we get an asymptote when my sine curve was at 0? Well, what's the reciprocal of 0? It's going to be 1 over 0, or undefined. So where sine is 0, the cosecant curve is going to be undefined. Another interesting point is coming up here, and that's when sine is 1, right there. I didn't quite get it paused. But if you notice here, when sine is 1, what's the reciprocal of 1? It should be 1 over 1, which is also 1. So you see when sine is 1, the cosecant is also 1. And we keep going through this pattern. When sine value is 0, the reciprocal is undefined. So we get an asymptote. Now notice down here, we're getting negative y values, so my reciprocals are also negative. What's the reciprocal of negative 1? No, it's negative 1, isn't it? So here is the relationship between cosecant and secant. I'm going to turn off sine. I'm sorry, I said that wrong. Relationship between sine and cosecant. So I'm going to turn sine off. This is what the cosecant curve looks like. A little bit like parabolas, only they have vertical asymptotes, and they're the cosecant curve. They're not parabolas. Secant, we're going to find a similar relationship between secant and cosine as we did with sine and cosecant. And again, you see those reciprocals coming into play here. There is actually, you can see this red line growing on the x-axis here. That is a connection as well, but I'm not going to go into it in this video. And so you see really a similar graph to cosecant. Okay, pause that. I just want to point out, if you know what the sine curve looks like, you can get the cosecant curve pretty quickly. So if you know that the cosine, I said that, I'm mixing up my words today, I'm sorry. If you know what the cosine curve looks like, you can find secant pretty easily. So if you know cosine starts at 0, 1, well then you know the reciprocal of 1 is 1, and so the secant has a point at 1, 1 right here. And if you know that, you can kind of keep thinking through, Keep thinking through if you know that at negative pi, cosecant has a point at cosine has a point at -1, then you end up with the points that are the minimums and the maximums for the cosecant or the secant curve. So in other words, let me say that again. If you can find the minimums and maximums for the cosine curve, that gives you the minimums and maximums of the secant curve. And then you just know that the vertical asymptotes are halfway in between those, and it's pretty quick to sketch. Cotangent, similar to relation. We see a similar relation between tangent and cotangent that we saw between the other ones. Now, it ends up being slightly different, but you can see here, it looks very similar to the tangent curve, and it just ends up being the reciprocal of the tangent curve. And so I'm going to come down here and turn on, that was tangent, I'm sorry. Let me turn on cotangent. And so it's hard to tell which is which here, but you can see that reciprocal coming into play. Wherever the values are 0 on tangent, then cotangent's undefined. Wherever the values are 1 or -1 on tangent, they are also 1 and -1 on cotangent. So again, probably the most useful, or what you'll see most people kind of thinking about remembering, is just what that general